So a mass spectrometer is an instrument that measures the mass of molecules and molecular fragments, molecule fragments that we're going to talk about, okay? So the way it works is we put a molecule sample into the vacuum where it should vaporize. We then bombard that sample with high energy electrons. That causes an electron to be detached from the molecule, making a cation. So I'm going to show you kind of a generic equation that's used for this. So really quickly, to sort of explain this, if you imagine that a molecule has an electron cloud, and we shoot an electron at that molecule really, really quickly, what we essentially get is we get a collision, okay? But the thing that you need to understand about electron collisions is that they aren't like car collisions, okay? Like when a car hits a car, they're both these solid objects. They hit each other, they stop each other, they crunch, okay? Electrons are like clouds. And the collision that we talk about is just that because they have the same charge, they repel each other. So it's sort of an issue of like you're shooting this charge at another charge, and they repel each other. So they get close. It's like, how close can you get them before the repulsion stops them and then pushes them apart, if that makes sense. So the electrons themselves never really touch, but because they have this force between them, the force gets really large, okay? And so when we have an electron going fast enough, we can force that electron to get extremely close. And what we have then is, in this region, we have a really strong repulsive force. And what that does is that causes another electron to be pushed out. So the first electron just blasts through, and another electron kind of gets repelled and gets knocked out. So hopefully that makes sense. And so what we get then is we get two electrons leaving. And typically, since a molecule is going to start with an even number of valence electrons or total electrons, what will happen is then the molecule fragment then will have an odd number of electrons, so it will become a free radical. The other thing that will happen is that because you're taking electron away, at the start, the number of positive charges in the nucleus, the number of negative charges were balanced. But when we take an electron away, now we have too many positive charges, or we have an excess of positive charges. So it becomes a cation. So we call this thing a radical cation. It's a charged particle. And then I'm going to show you down in the next section, we'll use a magnetic field. So when I draw the picture of the instrument, it'll become a little clearer how that works, okay? Sorry, this was supposed to be section B. Okay, so let me draw a picture of just a very diagrammatic picture of what a mass spectrometer would look like. And one thing I'm going to tell you is that I'm going to be drawing a very traditional instrument, I would say. There's one of the things that's gone on in the last 30 or 40 years, actually now, but is that they've developed new ways of using magnetic fields to sort of sort the ions. But I'm going to show you like the original way, okay? The heart of the original instrument is this. the magnetic field magnet. What we have at the beginning then is this, okay? So this is called the sample inlet. It's where the particles come in, okay? Then here, what happens is we have an electron gun, and the electron gun shoots electrons. Let me do them in red, I guess. Perpendicular to the inlet stream, okay? So the inlet molecules are sort of moving in this direction, and the electron gun cuts across them, and so they shoot the electrons, they collide, okay? Then there's a piece called a focuser, and what that does is that sort of accelerates the ions, forms a beam of electrons, basically. Okay, then we have this magnet. So when you put an ion into a magnetic field, the magnetic field causes the ion to move in it puts force on the ion. And so if the ion is moving as the force is applied, the ion moves in a curve. Okay, but the force is dependent on the strength of the magnetic field. And so what will happen is all of the different weights of ions will move in different trajectories. So I'm going to try to draw this, but so we'll have one that'll move like that, but it won't be far enough. We'll have another one that'll move like that, but it'll hit the wall here. But there should be one ion mass that would be perfect to go all the way through the curve. So the ions go into the magnet starts causing them to curve. Well, an ion that's really heavy will not get moved enough, right? Because force is equal to mass times acceleration. So it's got a fixed force, the mass is fixed, so the acceleration will not be enough, and it won't be able to make it through the curve. It'll hit the wall on the outside. If the ion is too light, it'll get deflected too much, and it'll just go boom, crash into the wall immediately. But there should be some mass, exact mass, that would be exactly the right relationship where the thing would go perfectly around the curve and come out on the other end. And then what they have is a detector. And then all of this is hooked up to, like a recorder or a computer. So the one that when I was an undergraduate, I took a class in instruments. We had at my undergraduate school a pretty old mass spectrometer, and it just had like a little paper strip chart recorder that you'd start it, and it would turn up at a certain rate, and it'd draw a thing, and when it got something, it would make a line, it would make another line. And then we'd have to like go and measure with rulers and do calculations and whatever. These days, they pretty much come out on computers, okay? And the result looks something like this, where down here, this is the mass to charge ratio, not ration, ratio, okay? M over Z, and I'll explain that in just a minute. And then these are numbers, like this might be 100, this might be 75, 50, and so forth. And then what you get is you get these lines like that. That means that there were ions. Okay. And using this, we can, first of all, hopefully get the rough atomic mass of the particle. And then also, it turns out we're going to talk about how the the particles themselves, the molecules break apart when they get hit with this force. So it makes these fragments, and we can kind of look at the fragments and use that to also figure out stuff about the structure. Some people who are like really experts in mass spectrometry, and I am not one of those, I'll be honest with you, but they can probably work out almost exactly what the structure is just from the mass spectrum, but I'm lazy and I prefer to use NMR. But mass spectrometry plus NMR plus IR, the three of them together, is an amazing tool. You can pretty much work out the spectrum of the structure of very, very complex molecules with this. Okay,